The first property says if you transpose the same matrix twice, you will get back the matrix A. Whenever the transpose of a matrix is equal to minus of that matrix, that is negative of a matrix, then it is called as a skew symmetric matrix. Any square matrix can be expressed as a sum of symmetric as well as skew symmetric matrix in the way A is equal to P plus Q. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So in the previous session we have learnt about the operation on matrices, that is how to add, subtract, multiply or multiply any scalar to matrices, and we have learned some important problems for your examinations also. And here in this session we are studying about the transposes of a matrices. What do you mean by transpose of a matrices? A transpose is nothing but interchanging rows into columns or column into rows. For example, if I take matrix A is equal to some 1, 2, 3, 4, 5, 6. So this is an order of 3 cross 2 matrix, correct? So we have 3 rows and 2 columns here. So if you interchange columns into rows, that is if you write column in terms of rows. So that is here we have 1, 3, 5. So we'll write it in rows now, and here we have 2, 4, 6. So the order is now 2 cross 3. That is you have 2 rows and 3 columns. So either you write rows into columns or columns into row. This is called as the transpose of a matrix. So transpose of a matrix is obtained by interchanging its rows and columns in matrix, and it is denoted by A dash or A to the power T. So we call it as A transpose. Now let's see some properties of the transpose of a matrices. So the first property says if you transpose the same matrix twice, you will get back the matrix A. So I have taken an example of A and A dash here. So if A is transposed, we get A dash. Now suppose if A dash is also transposed, it is called as A double dash, correct? Now let us transpose this. So then it will become 1, 2, 3, 4, 5 and 6. So this is the new matrix which is equal to A only. So therefore, when you transpose a matrix twice, you will get back the same matrix. And the second property says when you have when you multiply any scalar quantity with respect to matrix A and then transpose it, it is same as transposed matrix multiplied with K. So this we can prove by taking examples also. Another statement or another property says A plus B whole dash is A dash plus B dash, or we can say the transpose of A plus B is nothing but A transpose plus B transpose. Next, similarly, if you have AB whole transpose, then it is B transpose A transpose. Do not write it as A transpose B transpose. So this is a very important result which is asked for your examinations also for 5 marks question. So AB whole transpose is equal to B transpose A transpose. So these are the some properties of transpose of a matrix which you should remember. So let's see a few problems now. If matrix A is equal to 3 root 3 2 4 2 0 and matrix B is 2 minus 1 2 1 2 4, verify that A double dash is equal to A, KB whole dash is equal to KB dash, or A plus B whole dash is equal to A dash plus B dash. So instead of dash, you can also say the transpose. So here, let's see now. So we have A transpose, whole transpose. So we have A. So let's solve the first one. Let's see, take A transpose. Then it becomes 3 root 3 2 and 4 2 0. Now let us transpose it again. If you transpose it, 3, 4, root 3, 2, 2, 0. Isn't it one and the same here? So this is equal to A. So therefore we conclude A double transpose is always A. Now let's see the second one. we need KB whole dash. So first let us multiply KB. So KB means what happens here? Let's see KB. So KB is here, 2 minus 1, 2 means it is 2K minus K, 2K. Next we have 1, 2, 4, that is K, 2K, 4K. So this is KB. Now let's take KB whole dash. So then it becomes 2K, K, minus K, 2K, 2K, 4K. Let me take this as equation 1 now. Now this has to be equal to K into B dash. So let's multiply K with respect to B dash. Let's see B dash. We have B dash or B transpose is writing rows into columns. That is 2, minus 1, 2, 1, 2, 4. Now let's multiply K here. This becomes 2K, K, minus K, 2K, 2K, 4K. So take this as equation 2. Observe 1 and 2. So therefore what we can conclude? The transpose of KB is nothing but K into B transpose. So hence we have proved the result. So now next is we have to show that A plus B whole transpose is equal to A transpose plus B transpose. First let us find out A transpose and B transpose, or we can also first find A plus B then take a transpose. If you add A plus B, what you will get? So let's take A plus B. So A plus B means adding these two. So 3 plus 2 is 5. Next root 3 minus 1 we have. So root 3 minus 1. Next 2 plus 2, 4. Next we have 4 plus 1, 5. Next we have 2 plus 2, 4. Next 0 plus 4, 4. Remember, when you are adding any two matrices, their order must be same. Both should have the same order. Then only we can add. Let's take the transpose of this matrix. So then it is 5, 5, root 3 minus 1, 4, 4, 4. So this is equation 1. Now let's take A transpose plus B transpose. So let's write A transpose first. That is 3 root 3, 2, 4, 2, 0. And plus, what is B transpose? We can take 2 minus 1, 2, 1, 2, 4. Let's add these two now. So we get 5, 5, root 3 minus 1, 4, 4, 4. So take this as equation 2. So from 1 and 2, what we can conclude? A plus B whole transpose is A transpose plus B transpose. So these are few properties of the transpose of matrices. Next question. If A is equal to minus 2, 4, 5 and B is equal to 1, 3, minus 6, verify AB whole transpose is equal to B transpose into A transpose. So we have AB. So what is the order of this matrix? This is 3 rows, 1 column, and this is 1 row into 3 column. To multiply any two matrices, what is the rule we need? The number of column in the first matrix must be equal to the number of rows in the second matrix, so that the resultant matrix will be in the form of 3 cross 3. The order of matrix AB will be 3 cross 3. That means you should have 3 into 3, 9 elements, remember. So let's take AB now. So let's multiply first row to all the columns. Minus 2 into 1, minus 2. Minus 2 into 3, minus 6. Minus 2 into minus 6, plus 12. So this is done. Next, second row with respect to the 3 columns. 4 ones are 4. 4 threes are 12. 4 6 are 24. Next, the last row with the 3 columns. 5 ones are 5. 5 threes are 15. 5 into minus 6, 30. So if this is AB, let's take AB whole transpose. What happens? So we have minus 2, minus 6 and 12. And here we have 4, 12, minus 24. 4, 12, minus 24. Next 5, 15, minus 30. 5, 15 minus 30. So now this is AB whole transpose. Let me take it as equation 1. Now let's take B transpose into A transpose. Here we have B. Let's write B transpose. So it becomes 1, 3 minus 6. Let's write A transpose. It is minus 2, 4, 5. Now let's multiply this. What happens? 1 into minus 2, 4, 5. That is multiplying 1 to this. Next multiply 3 to this. So you will get minus 6, 12, 15. Next multiply minus 6 into minus 2, that is 12. Again minus 24 and minus 30. So observe this as equation 2. See equation 1 and equation 2. So therefore what I can conclude, AB whole transpose is equal to B transpose into A transpose. So this is again an important 5-mark question which can be asked for your examination. Very simple when you know how to multiply these matrices. Next we come across a very important topic called symmetric and skew-symmetric matrices. What is this symmetric and skew-symmetric matrices? Symmetric and skew-symmetric matrices is only for the square matrix. It is not defined for any other type of matrices. It is defined only for square matrices. So when you transpose any matrix, if A transpose is same as A. So if you transpose the matrix, then it is same as the matrix A. It is called as symmetric matrices. If it is equal to minus A, that is negative of the given matrix, then it is skew-symmetric matrices. Remember, a square matrix Aij, we know that Ij represent the column number as well as the row number in the matrix of order m cross n, is said to be symmetric if A transpose is equal to A. That is, if A transpose is equal to A for all possible values of I and j. And if square matrix A is said to be skew-symmetric, when it is said to be skew-symmetric, if A transpose is equal to minus A, then we call it as a skew-symmetric matrix. Let me take an example. If I take A is equal to 2, minus 1, 5. Let's transpose this matrix. If you transpose this matrix, it is 2, minus 1, 5. So this is same as A. A dash is A. So therefore, this is an example of symmetric matrix. Now, let us take an example of skew-symmetric matrix. So before taking an example, note that in a skew-symmetric matrix, all diagonal elements are 0. So what do you mean by diagonal elements in a square matrix? The elements in A11, A22, A33. So that is the principal diagonal elements are called as diagonal elements. So in a skew-symmetric matrix, the diagonal elements are always 0. So therefore, let me take an example of B. So here it is 0, minus 1, 2, 1, 0, 3, minus 2, minus 3, 0. Take the transpose of this matrix. So it is 0, 1, minus 2, minus 1, 0, minus 3, 2, 3, 0. So this is not equal, but take minus outside here. If you take minus outside, then it becomes 0, minus 1, 2, and here it is 1, 0, 3, and here it is minus 2, minus 3, 0. See here, these are one and the same, and this is equal to minus B. So whenever the transpose of a matrix is equal to minus of that matrix, that is negative of a matrix, then it is called as a skew-symmetric matrix. Next, we come across a theorems that what does it says? For any square matrix A with real number entries, A plus A transpose is a symmetric matrix and A minus A transpose is a skew-symmetric matrix. Let me take an example of A. A is equal to 1, 2, 3, 5. So what does the theorem says? If A is a matrix with real number entries, then A plus A dash or A plus A transpose must be a symmetric, and A minus A dash or A minus A transpose must be skew symmetric. Let me take A transpose. It is 1, 2, 3, 5. Let me see what is A plus A dash. A plus A dash is 1 plus 1, 2. 2 plus 3 is 5. 3 plus 2, 5. 5 plus 5, 10. So let's see whether it is a symmetric or not. How to see whether it is a symmetric or not? Transpose this. A plus A dash whole transpose. So to check whether A plus A dash is symmetric, we have to take the transpose of A plus A dash. So therefore it is again 2, 5, 5, 10. So therefore according to the theorem, A plus A transpose is a symmetric. Now let's see A minus A dash or A minus A transpose. 1 minus 1, 0. 2 minus 3, minus 1, 1, 0. Let me take the transpose of this matrix. So this is 0, 1 we have, 0, 1, and here minus 1, 0. If you take minus outside, it is 0, minus 1, 1, 0. So that is equal to minus of A minus A transpose. So clearly A minus A dash whole transpose is minus of A minus A dash or minus of A minus A transpose. Hence, for all the matrix A with real number entries, A plus A transpose is always symmetric. A minus A dash is always skew symmetric matrix. Next, one more theorem we have. Any square matrix can be expressed as the sum of symmetric and a skew symmetric matrix. So suppose we have a matrix A, okay, then we can express it as a sum of P plus Q, where P is half of A plus A transpose. What is A plus A transpose? It's a symmetric matrix according to theorem 1. And Q is given by half of A minus A transpose. That is, A minus A transpose is skew symmetric matrix according to theorem 1. Hence, any matrix or any square matrix, I already told you symmetric and skew symmetric only defined for square matrix. So therefore, any square matrix can be expressed as a sum of symmetric as well as skew symmetric matrix in the way A is equal to P plus Q, where P is half of A plus A transpose and Q is half of A minus A transpose. Now let's take few problems on transpose of a matrix. So if A dash is equal to minus 2, 3, 1, 2 and B is equal to minus 1, 0, 1, 2, then find A plus 2B whole transpose. So here we need A, but they have given A transpose. So if A transpose is transposed again, then we will get back A. We know this property, right? A double transpose is A. So therefore what is A? Minus 2, 3, 1, 2. Next we need 2B. 2B means just multiply a scalar 2 with all the elements inside the matrix. Minus 2, 0, 2, 4. Now let's take A plus 2B. Add the two matrices. Minus 2, so it is 0. 1 plus 0, 1. 3 plus 2, 5. 2 plus 4, 6. Now let's take the transpose of this matrix. So it is 0, 5, 1, 6. Next question. If A is equal to cos alpha sin alpha minus sin alpha cos alpha, then verify that A transpose is equal to I. What is I? I is an identity matrix or unit matrix. Since here matrix A is of order 2 cross 2, I must be of order 2 cross 2. That is 1, 0, 0, 1. Now let's take A transpose of this. So that is cos alpha minus sin alpha, cos alpha. Let's multiply A transpose. First row into first column. Cos alpha into cos alpha, cos square alpha. Next we have here sin alpha into sin alpha plus sin square alpha. Next, first row into second column. Cos into minus sign, we get minus cos alpha sin alpha plus sine into cos. That is cos alpha, sine alpha. Similarly, we will multiply the second row with first column. Minus sine into cos becomes minus sine alpha, cos alpha. Next, we have cos alpha into sine alpha. That is sine alpha, cos alpha. Next, second row, second column. We get it as minus into minus plus. So, it is sine square alpha and cos alpha into cos alpha, cos square alpha. So, we know that here cos square alpha plus sine square alpha is 1 and here it cancels. Here it cancels. So, it is 0 and 0 here. Again sine square alpha plus cos square alpha is 1, which is an identity matrix. Hence, we proved it. Next one. Show that the matrix A is symmetric matrix. To show that any matrix is symmetric, just transpose it. Let me take the transpose of this matrix. Write the rows into columns. So, 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. Isn't it same as the matrix given here? So, none of the element is changed here. It is one and the same. This is equal to A. So, therefore, the given matrix is a symmetric matrix. In the similar way, we can also show the given matrix is a skew symmetric matrix by taking minus outside and writing it in the form of A transpose is equal to minus A. Next question. For the matrix A is equal to 1, 5, 6, 7, first one we have to show that A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. So, this is from the theorem. We already known that by taking an example. Let's prove it again. So, we have A here. Let me take A transpose. What is A transpose? 1, 5, 6, 7. So, here first one, A plus A transpose. How much we will get? 1 plus 1, 2, 11, 11, 7, 7, 14. Let me take the transpose of this matrix. A plus A transpose whole transpose. We get 2, 11, 11, 14. So, this is same as A plus A dash. So, therefore, what we can conclude? A plus A dash is a symmetric matrix. Next, we will see A minus A dash. What is A minus A dash? So, 1 minus 1, 0, 5 minus 6, minus 1, 6 minus 5, 1, 7 minus 7, 0. Let me take the transpose of this matrix. Take the transpose. So, it is 0, 1, minus 1, 0. Take minus outside. 0, minus 1, 1, 0. So, clearly A minus A transpose whole transpose is equal to minus of A minus A transpose. So, therefore, A minus A transpose is a skew symmetric matrix. Next problem we have. Express the matrix 3, 5, 1, minus 1 as the sum of symmetric and a skew symmetric matrix. So, this is the theorem 2. I already said you, let matrix A is equal to 3, 5, 1, minus 1. Okay. So, let's take A transpose. So, then it is 3, 5, 1, minus 1. Next, let A is equal to P plus Q. Okay, where P is equal to half of A plus A transpose and Q is equal to half of A minus A transpose. Okay, so here let's solve for P and Q. First, let us see what is A plus A dash. So, let's take A plus A dash. So, here what is A plus A dash? It is 3 plus 3, 6. Next, we have 5 plus 1, 6. Next, we have 1 plus 5, 6. Next, we have minus 1 plus minus 1, minus 2. So let's take half of a plus a dash. What is half of a plus a dash? 3, 3, 3 minus. This is actually what? P. So P must be symmetric matrix. Let me take P dash. So P dash is what? 3, 3, 3 minus 1. So therefore this is P. So what we can conclude, therefore P is symmetric. And similarly, let me take here A minus A dash. So A minus A dash means here 3 minus 3, 0, 5 minus 1, 4, 1 minus 5 minus 4, minus 1 minus of minus 1 becomes 0. So it is 0, 4, minus 4, 0. Let me take half of A minus A dash. So this is 0, 2, minus 2, 0. So this is actually Q. Let me see Q dash. Q dash is 0, minus 2, 2, 0. Take minus outside here. Then it becomes 0, 2, minus 2, 0. So therefore, Q dash is equal to minus Q. So therefore, Q is skew symmetric. So now let's add P plus Q. P is actually symmetric and Q is actually skew symmetric. Let me add P and Q here. So P is this and Q is this. So 3 plus 0, 3, 3 plus 2, 5, 3 plus 2, 5 and minus 1 and Q is 0, minus 1. What is this actually? The matrix A, which is 3, 5. Now let's add P plus Q. So this is our P and this is our Q. So let's add it. 3 plus 0, 3. Next 3 plus 2, 5. 3 plus minus 2, 1. Minus 1 plus 0, minus 1. So what is this? This is actually our matrix A. Hence, matrix A can be expressed as a sum of symmetric as well as skew symmetric matrix. Hence, we have proved it. So, whenever the matrix is given, just find the transpose and express it as P plus Q, where P can be verified with this formula and Q can be verified with this formula. Then show that P is symmetric and Q is symmetric. Add it again and show that it is equal to A. Thus, we can show that any square matrix can be represented as the sum of symmetric and skew symmetric matrices. This is all about the transpose of matrices. We'll meet you with a new concept in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.